Hello, welcome to Linear Algebra with NumPy preview video. In this video, we are going to study the system of equations called ax equal to b and study the shape of the solution set. Okay, the difference between this video and the previous video is this part. Previously, we studied ax equal to 0. That set is called the kernel. Now we study ax equal to b, and this is a more general setting. So again, a system of linear equations corresponds to a matrix vector multiplication. And now b is a bit different. It is not necessarily to be 0. So suppose we want to solve such an equation, then we can try to find at least one solution. For example, we can find p equal to 1, 2, 0, then it is the solution to this equation. Now I want to make an observation. Let's fall back to the same equation we did last time, ax equal to 0. Okay, so 1 minus 1, 0, it is the solution to ax equal to 0. Okay, notice that the equations are different. But if I have a p, a solution of ax equal to b, and h, a solution to ax equal to 0, and when I take the sum of that, then it is the solution to ax equal to b. Why? Because whenever I do a multiplied by the sum of p and h, then it is ap plus ah. But ah is 0 because it is the solution. It is of this one and it is the kernel. So it is equal to b. So it turns out that whenever you have one solution p and you have a lot of kernel vector, you just pick any vector in kernel, p plus whatever h, it is still, again, a solution. So the takeaway of this video is that the solution set of ax equal to b is basically the same as the kernel, but you will shift this kernel by a vector p. And here is the picture. This set is the kernel. It is all the vector ax h with ax equal to 0. Okay, and whenever you have an edge and you have a particular p, this a times p is equal to b. Okay, it is a solution. So whenever you add h here, p plus h is a solution. You have another h, p plus h is another solution. So basically, you have all the kernel here, and then you shift by p. This is the shape of the solution of ax equal to b. Now let's look at the code. The code is pretty much the same as previous because now we know how to plot the solution. We know how to plot the kernel. So we plot that by 3 dimensions, but now a little bit different is how do we plot the solution of ax equal to b. Okay, so you will see this line is very much similar with the previous video. You have a lot of points, a times x. Now what is this one? Well, b is just the 2 vector, right? And then if I do column and the np.newaxis, it just means that I want to put all the numbers in this place, and then I want the new axis here. So it becomes a 2 by 1 matrix. So it becomes the column vector. But it still does not make sense because this is the 2 by 100,000 matrix and minus a 2 by 1 matrix. Their sizes are different. So this is called the broadcasting feature in NumPy. If you have a matrix minus something like this, then in the end it will broadcast a lot of b here. It is ax1 minus b, ax2 minus b, and then you are curious about which ax minus b is very close to 0. So we use the same technique to do the mask and then plot the solution set. And lastly, this just try to plot this p vector, which is the red arrow. So we see that the solution set is the kernel shifted by p.